afternoon. Welcome to our science class. I just want to remind you all to turn off your audio on your cam, and then you can use chat box if you want to say something. So let's proceed. Okay, before we start, let us have a prayer. Lord, thank you for this day, for the presence of everyone in this call. For once again, we are gathered and given the opportunity to appreciate life and your words. Forgive us for our shortcomings and cleanse our hearts as we learn and live your words. An example. Father, bless our endeavors, especially today's meeting. May you guide us in our discussions and may you enlighten our minds in every decision that we make. Give us your grace that we may effectively do our parts.
Okay, so our topic for today is all about three laws of motion. So we have three laws of motion here. Law of inertia, the first. Second is law of acceleration, and then the third one is law of interaction. Sir Isaac Newton invented the three laws of motion in year 1686. It describes the motion of massive bodies and how they interact. Law of inertia, a tendency to do nothing or to remain unchanged. An animal is sleeping. That's why we have it. Okay.
Inertia. Okay, so let us define first what mass is. Mass is the amount of matter in an object, and then the inertia is a tendency of an object to resist any change in state. So the relationship of mass is when a mass or when a matter has more mass, it means it has more inertia. When a matter has less mass, it means it has less inertia. Okay, next. So of these two examples, which has more mass and more inertia? Of course, we'll choose elephant because it has more mass. Okay, we'll be choosing elephant because it has more mass and inertia, as we discussed earlier. And the one which has less mass here and inertia is a chicken. Okay, based on what we heard and discussed earlier on this topic. Next is we can apply same concept on these two new example. A car has more inertia and has more mass, and then the ball has less inertia and less mass. Okay, next. Law of inertia states that an object at rest will remain at rest unless acted upon by unbalanced external force. Example for this are apple on the floor or things on the top of the table. Next is states that an object in motion unless acted upon by unbalanced external force. Okay, so we can make these examples stop, okay, or move, and it is because of the unbalanced force, unbalanced external force. Okay, next. Law of acceleration. Acceleration is the rate at which velocity changes. So acceleration can result from a change in speed, increase or decrease, change in direction, back, forth, up, down, left, right, or changes in both. Like velocity, acceleration is a vector. Okay, formula for acceleration. We have three quantities: force, acceleration, and mass. Force, F is for force, A is for acceleration, and M is for mass. The unit for force is Newton, or kilogram meter per second square. And then acceleration, is symbol for acceleration is A, and the unit is meter per second square. The quantity for mass, the mass quantity, its symbol is M, small letter M, and the unit is kg. Okay, we have different formula for different quantities. We have F, or force. If we'll be finding F, force is you need to get the quotient of the mass, not the quotient, I'm sorry, get the product of mass and acceleration. You have to multiply mass and acceleration. Next is, if you will be finding acceleration here, you need to get the quotient of force over mass. Okay, and for M is you have to get the quotient of force over acceleration. So this symbol is very reliable, okay, when it comes to formula. Just need to use this one. Okay, you don't have to memorize these three formula, but you just have to have this. Okay, symbol F is on the top, and then divided by the product of mass and acceleration. So next, let us have the first question. What is the net force of an object if it has an acceleration of 200 meter per second square and a mass of 0.5 kilogram? Okay, so we determine the acceleration and the mass using the reference. We are asked to get the force. So the force is the product of mass and acceleration. So we already have the mass and acceleration, and its unit 0.5 kilogram for mass and meter per second square for acceleration. We just multiply it. Okay, let's get the calculator for us to be sure. Okay, so mass multiplied by 200, or acceleration, we have 0.5 times 200 is equals to 100. So the force is 100 Newton, or N, or kilogram meter per second square. So we need to include the unit, okay, use for finding force. Next, Lisa is running across the park and she has a mass. So the mass is given already of 45 kilogram and an applied force of 125 Newton. Determine her acceleration. Okay, so actually mali yung pagkakalagay nito eh. Typographical. Gawin na lang natin to 50. Okay. We need to change this for 50. Okay, so let's change this number to 50. The force is 125 Newton and then the mass of 50 kilogram. We are asked to find the acceleration using the reference, which is the delta here. Finding the acceleration is you need to get the quotient of force and mass. Okay, so force divided by mass. Let's get the calculator. Force of 125, okay, divided by 0.50, and not 0.50 but 50 only. So 2.5 meter per second square as its unit. Acceleration 2.5 meter per second square. Okay, Next, determine the mass of a car if the exerted force is 1,340 Newton and the acceleration is 40 meter per second square. So for the force, 1,340 Newton, and then acceleration is meter per second square. So we'll be finding the mass. So mass, the formula for mass is the quotient of force and acceleration. Let's get the calculator. Okay, so 1,340 divided by 40. Okay, so 33.5 is the mass. As easy as that. Okay, bottom. Okay, law of interaction states that for every action there is an equal and opposite reaction. Action is equals to reaction. So we have an example here. Man pushes up his body, and then people playing tug of war, and then the third one would be a man playing his skateboard or scooter, wherein he is applying force on the ground for him to move. Okay, so that's how law of interaction works. It gives you, or it gives you same amount of force. Okay. Okay, so I have here a task for you to complete for reference only. Okay, for you to answer the law of acceleration, you need to fill those blanks using the formula I've shown you. Okay, if you learn on this lesson, you may like, share, and subscribe. Okay, if you haven't subscribed yet, press the subscribe button. Okay, thank you. Bye.